We have been studying some of the important types of signals, and in our last lecture, we have completed the first type, which was continuous and discrete time signal. In today's video, we'll talk about the second and third important types of signals, which are periodic and aperiodic signals, and even and odd signals. So, starting from the definitions of periodic and aperiodic signals, as the name suggests, that a signal is periodic signal if it completes a pattern within a measurable time frame and repeats that pattern over identical subsequent period. These signals look like this, and obviously the opposite of a periodic signal is an aperiodic signal. An aperiodic signal never repeats itself. Now, few examples of aperiodic signals are shown in this picture. Let's see how we can plot periodic and aperiodic functions on MATLAB. This expression for the sawtooth function is this in comments: x equals to sawtooth 2 pi omega t, where 2 pi omega t is the angular frequency. So first of all, set the time period as t equals 0 to 0.1 with the spacing of 1 divided by 1000. Now for frequency, take omega is equals to, let's say I'm taking 50, and type the expression. So x equals, we'll use the function sawtooth here, and 2 pi omega t. Now plot the graph by using plot command. And you can see that as the result shows, the signal is repeating itself after the constant time period, means it's a periodic function. Now let's see aperiodic signals. First, define time period. T equals from -1 to +1 with the spacing of 1 divided by 1000. And here we'll take frequency, or omega, equals to 20 exponent minus 3. Now take variable x1 equals the built-in function for the triangular pulse named tripulse, and t comma omega. Now plot this function, and put the title for this plot like this, and enter. You can see that since it's only a pulse and not repeating after a constant time period, so it's an aperiodic signal. Now let's talk about another type of a signal, which is even and odd signals. So what even signals are? A signal x of t or x of n is an even signal if it is identical to its time reversed counterpart, or you can say that even signal is symmetric around vertical axis. As you can see here, x of t or x of n should be equals to x of minus t or x of minus n to be even signal. Now odd signals. A signal x of t or x of n is an odd signal if it is not identical to its time reversed counterpart. At t equals to 0, the odd signal must be 0. And here is the formula for odd signals. Now let's type a code for even and odd signals. First, as always, define the time period for which you want your signal to exist. Here I'm taking t equals to from -5 to +5 with 0.001 of spacing. Now define two functions, x1 and x2, like that. And you can see that x2 has negative t, which means that it will produce mirror image of signal x1 but at -t or on negative x-axis. Now define two more variables for even and odd signals. Now start plotting. We know that when we want to plot multiple graphs on the same page, we use the function subplot. So subplot 2 comma 2 comma 1. Here 2 comma 2 is representing the total number of rows and columns. Here we want to plot 4 graphs, so we'll take 2 rows and 2 columns. And this one is because it's the first plot. Now type the command plot and plot x1. We are considering time on x-axis, so give it a tag of t by using function called xLabel. And for y-label, we have our signal, so take x of t on y-axis, like this. And since we are plotting x1, which is our pure signal, so give the title of signal x of t. Now coming to our next plot, again type subplot and number of rows and columns. And since it's our second plot, so 2 is for that. Plot x2. Here I am giving the title of x of minus t. Similarly for the third plot, which is for even signal, give the title of even part signal. And finally for odd part, since we are done with the code, now let's run this. You can see that on the left side we have our first graph, which is our pure signal. Second graph shows the mirror image of the first, while the third one is same graph as our pure x of t, but it is plotted on the negative x-axis. The fourth one is odd part because it is the flipped version of the original signal x of t. So that's all from the types of signals, and in our next video we'll be dealing with different operations that can be performed on signals.